In this video, we will learn how to interpret a topographic map for the purposes of reading and understanding. Contour maps can be very intimidating at first, but with a bit of instruction, comprehending these maps becomes a relatively easy task. The first thing that needs to be discussed is what exactly is a contour. A contour is a line that connects points of equal elevation. For example, if you look at point 1 on the map, you can determine that the elevation of this contour is 300 feet by tracing a line through the map. Still following this line around, you can see that both point 2 and 3 are the same line. This contour line never crosses itself and still ends up being in the same general location as point 1. Now, how did we make the determination that the contour line was equal to 300 feet? We did this by locating the label on the contour line. This contour line is identified as an index contour line. An index contour line is used to help clarify the map through the usage of labels, as labeling every contour line on the map would make it illegible. It is for this reason that index contours are typically every fifth contour line, as can be identified by looking at points 4 and 5. So we now understand what a contour line is, but how do I read this map? One of the most important rules to remember about reading contour lines is that on one side of the line you have a higher elevation, and then on the other you have a lower elevation. By looking at the contours in the identified area shown in blue, you can see that as you move to the right of the map, the elevations continue to get higher, meaning that all points on the right side of these lines have a higher elevation than those to the left. With this information in our hands, we can begin to take this a bit further. How does one determine what the values of the non-labeled contour lines are? Through the usage of the index contours, we can determine the contour interval. The contour interval is the amount each contour line increases from the last. Using the area still identified in blue, we can calculate the contour interval of this map. Taking the two index contours, 100 feet and 200 feet, in this area, we can calculate the difference between the two to be 100 feet. Then we count the number of contours between the two, and we come up with 5. Note that when counting, you do not include the first contour line, but you do include the last, as you had to travel the distance from the last contour to get there. Now, with your known differences between the two indexes, and with the number of contours in between, you can divide 100 feet by 5 to come up with a value of 20 feet for the contour interval of this map. What this means is that as you progress through the map, every contour line in the map will be 20 feet higher or lower than the contour next to it. This now brings us to the next part of interpreting this map. What if you have a location that does not fall directly on a contour line? How do you determine its elevation? Let's use point 6 as an example of a scenario like this, as it resides between two contour lines. Using the index contour next to point 6, we know we have a value of 300 feet above it. The contour below this point will be 280 feet due to the contour interval, and noting that as you progress towards the south, you are approaching the 200-foot index contour. Now that we know the contour values, we can determine the elevation for point 6. What we do not do is assume the elevation for this point is 300 feet or 280 feet, as it does not reside on top of either of those contour lines. Instead, we use what is known as the half rule, which basically states that when a point resides between two contour lines, you take half the contour interval and add or subtract it to the contour next to the point to estimate the elevation of the location. In our situation, half the contour interval is 10 feet. And knowing the point is below the index contour, and in this area it is decreasing towards 200 feet, We subtract 10 feet from 300 feet to end up with an elevation of 290 feet for point 6. This same technique could have been done by using the 280-foot contour line and adding 10 feet to it. Either way of determining the elevation is the correct. Being able to use the half rule also helps to determine the elevation of high and low points on a map. When you have a closed contour within the map, they indicate the location of either a high point in the region, such as point 7, or a low point, such as point 8. Note, the way we can tell that point 8 is a low point, otherwise known as depression, is based on the hatchers which are attached to the contour line. These hatchers are the little lines that come off the contour line and point inwards towards the low point of the depression. Since there is no listed elevation for the high or low points on this map, we must use the index contour to determine what the elevation of the contour next to the high and low point is. For point 7, the contour next to the high point reads 400 feet. And for point 8, the contour next to the low point reads 200 feet. Again, since there is no listed elevation value within the remaining area of the two locations, we must use the half rule to estimate what the final elevation is for each point. We have already determined that any estimate between contour lines will be 10 feet higher or lower based on the half rule. Knowing this, we can estimate that point 7 will have an estimated elevation of 410 feet for its highest point, and that point 8 will have an estimated elevation of 190 feet for its lowest point. One final item to cover with respect to interpreting topographic maps is to understand what a visual inspection of the contour lines can indicate. We know that contour lines represent areas of equal elevation. However, what happens when you have a tight clustering of contour lines, as shown by the green box, compared to an area that has contour lines not as clustered, as shown in the orange box? What each of these areas show are areas of steep and gentle slopes. The area identified by the green box indicates an area with a steep slope based on the fact that there are 9 contour lines in that small area. When you compare this to the orange box, we can clearly see that this has a gentle slope, as a total of 3 contours are within that area. In short, a tight clustering of contour lines in an area indicates a steep slope, while a low clustering of contour lines in an area indicates a gentle slope. In summary, in this video we have learned how to interpret topographic maps. The key items we obtained from the discussion was an understanding of what a contour line is, which contour lines are classified as index contours, how to determine the contour interval of a map, and how to estimate elevation between contour lines based on this information. We also went over how to identify high and low points on a map, how to locate depressions on the map through locating hatchers, and how to determine the amount of slope an area has. Please feel free to share your comments and questions with your instructor regarding the content of this video, as well as to receive further guidance on the concepts covered.